For section 3.4, we're going to talk about slopes of lines and how it relates to parallel and perpendicular lines. So before we start, we need to look really at slope. And slope is simply a rate of change. And that when we talk about rate of change, it's the ratio of the vertical change to the horizontal change between any 2 points on a line. So if it's horizontal change to vertical change. You know what? I mixed it up already. Let's try that again. Vertical change to horizontal change. Now, vertical change, well, that's the change in y. And I'm going to use the symbol delta and say delta y. So the change in y is the vertical change. Horizontal change is the change in x. So I'm going to use the delta symbol for delta x. You may have also heard of this as rise over run, and that's commonly used because rise is that vertical change, and the run is how far it goes out. That's your horizontal change. It says, think of a triangle. If I had 2 points, this would be the run, and this would be the rise, and in any case, we could make a triangle to represent those distances, and that may help us on a graph as we're trying to count points to count the slope. Before we get into that, we have types of slope. A negative slope will go down from left to right. A positive slope will increase from left to right. A zero slope will be a horizontal line, and an undefined slope will be a vertical line. Now the way we're going to identify them, and I got a little ahead of myself, m is typically the variable we use, or the letter we use for slope. If we have a negative slope, we're saying that our value is a negative number. If we have a positive slope, it's a positive number. A zero slope is just that. The slope equal to 0. And an undefined is actually like an undefined number. So let's say we had some number divided by 0. If you had that, you would say it's undefined. So it works the same way here. And why that works is this line has no run. It has no change in x. It only moves in the vertical direction, so there's nothing up there. So let's talk what slope is really, though. Now we said it's the change in y. Let's try that again. The change in y over the change in x. So that's what slope is. Okay, well if I had 2 points, say 2, 3, and 6, 8. These are my x values. These are my y values. So my change in y would be, I went from 3 to 8. So it changed 5. My change in x, I went from 2 to 6. So it changed 4. So what I could really say is the ratio for the change in y to the change in x is the slope 5 over 4. Let's look at another one. Say I have negative 1, 3, and 4, 0. Still thinking of it the same way. Change in y over the change in x. My y value, I went from 3 to 0. I'm not going to say it changed 3. I'm going to say it changed negative 3, because it went from positive 3 to 0. 1 to 4 is my x change. I went from 1 to 4. That's 5. So I could say my slope is negative 3 over 5. Let me do another one. Negative 2, negative 3. And let's do negative 6 and negative 1. So change in y over change in x. I go from negative 3 to negative 1. I changed positive 2. Negative 2 to negative 6. I changed negative 4. So I would reduce that to negative 1/2 would be my slope. Now, what this may be different than what you've seen before. What you've seen before is the slope formula, which for the slope formula, we say m is equal to y2 minus y1 over x2 minus x1. It's really finding the change. It's finding the change in the rise. So if I had the two coordinates here, y1 and y2, I could subtract y2 minus y1 to find that distance. I can do x2 minus x1 to find that distance, and then it's still the ratio. You may use this, and that's fine. If you know the formula and you like the ability to plug into a formula, by all means, use the slope formula. But sometimes we overcomplicate things. If we're just looking for that change in y to the change in x, we can see what that change is as we go from our first point to our second point, and sometimes it clears things up. If I did slope formula for any of these, I'd get the same answer. So let's say for this last one we did, I said, all right, y2 minus y1 over x2 minus x1. So negative 1 minus a negative 3, we can make that a plus, so that's 2. Negative 6 minus a negative 2, make that a positive 2, so that's negative 4, comes out to still be negative 1/2. But I didn't have to use the formula. And again, it's an option, it's just another way to look at it as we go. So, let's skip ahead here. Look at some of these, and we'll do them in two ways. We'll do them with the slope formula, and then we'll check just by looking at the difference. So by the slope formula, let's label x1, y1, x2, y2. I would do y2 minus y1 over x2 minus x1. That's 0 minus 4 over negative 3 minus negative 2. So I get negative 4 over, make that a positive, negative 1, which comes out to be a slope of 4. If we look over here at change in y, change in x, I went from 4 to 0, it's negative 4. I went from negative 2 to negative 3, that's negative 1, and it still comes out to be a positive 4. So either way, it works. Okay, if we look at the slope for each of these, so if we look at A first, I go from this point, 6,4, to 8,2. If I'm looking at slope formula, that would be 4 minus 2 over 6 minus 8. Comes out to be 2 over negative 2, which is negative 1, which fits. It is a negative slope. If I look at the slope of B, I have 4, 0, and 6, 4. So that would be 4 minus 0, and 6 minus 4. That's 4 over 2, so I get a slope of 2, which is positive, 2 up 2 over 1, that fits. C, I have 0, 4, and 6, 4, so that would be 4 minus 4, 6 minus 0, which gives me 0 over 6, which is 0. Makes sense, 0 slope, horizontal line. D is a vertical line here. I have 6, 4, and 6, 0, so that's 4 minus 0, over 6 minus 6, that's 4 over 0, and that is undefined. Vertical line, that fits that one as well. Okay, so let's start applying it to where we're looking, parallel and perpendicular lines. So postulate 17 says, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. If I have two lines and I'm saying they're parallel, their slopes will be equal. Easy enough. If they're both equal 3, if they both equal 5, if they both equal 1/2, we can pretty much look at the values and identify it, or we could find the slopes and see they're equal. We know they're the same. So slopes are equal. For perpendicular lines, though, two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. So here I'm saying if I multiply my two slopes, I get negative 1. Well, let's take maybe a little different look at that. So this is what I have. I'm going to divide both sides by the slope of 2, line 2, and I get this. So the slope of 1 is equal to negative 1 divided by the slope of 2. And this actually brings up a term. We could call this the opposite reciprocal. The opposite reciprocal of one slope will be its perpendicular slope. So let's try that. If I had negative 3 and I took its opposite reciprocal, I would have positive 1/3. I changed the sign and flipped it in a fraction. If I checked that and multiplied the two, it comes out to negative 3 over 3, which is negative 1. So that works. If I did 4 over 3. And I did its opposite reciprocal, it'd be negative 3 over 4. If I then multiplied those two, I'd get negative 12 over 12, which is negative 1, so those would be perpendicular. So you can multiply the two, and that would be fine to see if they are negative 1, but if you kind of look for that shortcut of opposite reciprocals, it may make it a little bit easier. So let's start working through looking if we have parallel and perpendicular. So I have line K passes through those points, so the first thing I'm going to do is find line K. I could say 1 minus 3 over 4 minus negative 1. You get negative 2 over, and that becomes plus, so 5. Line T passes through those points, so I can find the slope of T. Negative 3 minus negative 1, and 3 minus negative 2. That becomes addition, that becomes addition, so I have negative 2 over 5. I get that the slope of K is equal to the slope of T. Now if you're not sure how we got the slopes, I went from 1 to 3 was my change in y, that's 2. I went from 4 to negative 1, that's negative 5, so I get negative 2/5 there. If I go from negative 1 to negative 3, that's a change of negative 2. If I go from negative 2 to 3, that's a change of 5, so I can even see there the slopes are equal, therefore K is parallel to T. Okay, we come down here, now we're looking at perpendicular. So we have line N. Let's find the slope of line N. If I go from 2 to 5, that's a change of 3. 0 to 6 is a change of 6, so my slope is 1/2. For the slope of K, I go from 4 to 0, that's negative 4. 2 to 4 is positive 2, so I get negative 2 for that. So I have 1/2 and negative 2. If I multiply those, because that's what I want to check if they're perpendicular, I get negative 2 over 2, which is negative 1. But we could also say 1/2 and negative 2 are opposite reciprocals. In either case, we get that N is perpendicular to K.